Hello friends, today we are going to discuss regarding the subject water resources engineering and its syllabus and contents which is present in the syllabus. So, if you see the teaching scheme, total theory lectures are allocated 3 lectures per week. Evaluation scheme, as you know that semester examination 1 will be of 25 marks, semester examination 2 will be of 25 marks and semester end examination will be of 50 marks. So, what are the course objectives of this subject? First one is to impart the basic knowledge of importance of the hydrology and irrigation, water resources development. Second is to know various hydrometeorological parameters and their estimation. Third is to understand the importance of irrigation in Indian agriculture industry considering the cropping patterns. Fourth one is to understand the importance of irrigation, principles of watershed management and water harvesting. So, we will see now the course outcomes. On completion of this course, students will be able to, first one is to understand the concept of hydrological cycle and quantify evaporation and infiltration processes. Second, analyze the concept of unit hydrograph and review various rational and conceptual rainfall runoff models. Third one is analyze performance of real-time flood forecasting. Fourth one, develop different methods of efficient irrigation and water conservation systems. Let us go to the course contents. Unit number 1, total lectures allocated are 8 lectures. What are the contents? Introduction of hydrology, definition, importance and scope of hydrology, the hydrological cycle, precipitation, forms and types of precipitation, methods of measurement, graphical representation of rainfall, mass rainfall curves, hydrograph, determination of average precipitation over the catchment, evaporation process, factors affecting measurement and control of evaporation, infiltration process, factors affecting and measurement of infiltration. Unit number 2, which is having a 6 lecture allocated, which includes runoff, factors affecting runoff, determination of annual runoff, rainfall runoff, relationship hydrograph, storm hydrograph, base flow and separation of base flow, direct runoff hydrograph, unit hydrograph, theory, assumptions and limitations, derivation and use of unit hydrograph, S-curve hydrograph. Then unit number 3, it is also having 6 lectures. Its contents are stream gauging, selection of site, discharge measurement by area velocity method, slope area method, floods, estimation of peak flow, empirical equations, rational methods, importance of design flood, standard project flood, maximum probable flood, introduction to flood frequency analysis. Then let us go to the unit number 4. It is having the 6 lectures. It includes groundwater hydrology, occurrence, distribution and classification of groundwater, Darcy's law, aquifer parameters, permeability, specific yield, specific retention, porosity, storage coefficient, transmissibility, hydraulics of well under steady flow conditions in confined and unconfined aquifers, specific capacity of well, recuperation test, constructional features of tube wells and open wells. Then unit number 5, which is having 8 lectures, introduction to irrigation, definition and necessity of irrigation, ill effects of irrigation, surface, subsurface, sprinkler irrigation, water logging and land drainage, minor irrigation works, general layout, main components and functioning, in that percolation tanks, KT weir, Bandhara irrigation, lift irrigation, watershed management, need and importance of watershed management, soil conservation measures, techniques of rainwater and groundwater harvesting. Then unit number 6, if you see, the 6 lectures are allocated, and contents are water requirement of crops, principal crops and crop seasons, cropping pattern and crop rotation, classes and availability of soil water, depth and frequency of irrigation, duty, delta, base period and their relationship, factors affecting duty, methods of improving duty, assessment and efficiency of irrigation water, gross command area, culturable command area calculations based on crop water requirement, estimation of evapotranspiration by Blenny-Cradle method and Penman method. Then textbooks and reference books which are required for this subject. Textbooks you can use as irrigation engineering by the S.K. Garg, and also engineering hydrology by Dr. K. Subramanya. The reference books are also there, hydrology and water resources by R.K. Sharma, Varshani and Gupta theory and design of irrigation structures, 3 volumes are there. Then irrigation and theory and practice of Michael, then Jaspal Singh and Acharya, water management, design of MIN canal structure, Satyanarayan and Murthy, and water and conservation, soil conservation by Ghansham Das. So these are the good books which are available, and the subject is very interesting. So today just I will tell you what are the contents which are we are going to study. So hydrological cycle, that we have already aware of that. So we are going to study this hydrological cycle in depth, so that water collected in the reservoir due to rainfall and the utilization of the same to the field, so that can be made very optimum level if we understand all these processes. For example, precipitation, then this transpiration, condensation, runoff, evaporation, transport, condensation, so infiltration, and all these parts of which this hydrological cycle, that we are going to study in depth, so that we can allocate the proper water to the fields. Then also we are going to study the various watershed areas, so where the water is collected, okay, by means of a typical pattern. So those pattern also we are going to study, and this also we are going to study various basins, river basins, and all these things are interconnected. Watershed or river basin or hydrological cycle, these are interconnected, so that the interconnection study that we are going to analyze. Then also we are going to study regarding the various types of dams in this. Then in the water resources, especially hydrological and hydraulic principle of design, various drainage systems, retention of ponds, then navigation, also flood controls, okay, especially dams and lakes. Okay, so water, if you see, the water is stored behind the dam, it is called the reservoir, and on the downstream side we are relieving the water by using the canals and all the structures which are canal, tributaries, okay, then troughs, etc. So all these elements we are going to study in depth. Also you can see these two particular figure. In the watershed also we will have to study regarding the various watershed divides, tributaries, regarding the watershed divides, again percolation of groundwater, aquifer, percolation in the groundwater by of the various phenomena. Then you can see also we are going to study regarding the various water retaining structures like bandharas. So also we are going to study regarding the KT weir, Kolhapur type weir. So these components also we are going to study, and accordingly the management of the water on field, that we are going to study. So this subject is very interesting. So in the coming lectures we are going to start with the content of that. So one by one lectures, so you can get the along with you will get the notes as well. So thank you very much for attending the lecture. Okay.